So sulfur compounds, other than having that smell, can actually come in two forms. They can be aerosols, which are once again solids or liquids, or they could be gaseous in their form. Natural sources are things like natural steam vents in the earth. So if you ever go to Yellowstone, Yellowstone has that smell. That's the sulfur coming out of the earth. Another one is in volcanic reactions, and then sea spray itself, like the ocean. Think of low tide smell, right? Anthropogenic sources are burning of sulfur-containing fossil fuels, things like coal and oil, as well as in processing things, so smelting ores or any type of reactionary that I want to try to smelt out or separate out materials. There are two main types of sulfur compounds. There's sulfur dioxides and sulfur trioxides. Sulfur trioxide is the one that we consider the acid rain. This is the acid rain compound. It's also the one that creates what's called acidic fog, which is this, it's basically acid rain cloud. Basically, it's a cloud that's made up of the condensation nuclei, or the material that the water droplets stuck to, happens to be sulfur trioxide. That's what it's stuck to in its particulate. So even in some ways, that fog was caused by pollution sources. Sulfur compounds in acid rain have obviously an acidic pH, and so they can erode away at things, specifically things like limestone. And then here you go, the lions in New York City, which they just did a restoration, so they don't look like that because they just got new ones in front of the library. But this is the old lion, for example. Nitrous oxides. Nitrous oxide is a non-toxic, colorless, odorless gas. Natural sources is biological processes like soil and water. Nitrous dioxide is toxic. It's a yellow or brownish color in gas. It's pungent and it's corrosive. And you can often see nitrous dioxides in the atmosphere, specifically when you get that early morning pollutant fog that sets in. And if you've ever traveled the world, if you noticed any of the stuff from like the Beijing Olympics or something along that, you'll see that reddish haze or that yellowish haze in the atmosphere. That's left over by the nitrous dioxide in the atmosphere, as well as sometimes staining on buildings and things. We also see it sometimes on the West Coast, so it comes rolling in on the fog, like out in San Francisco. As far as providing pollutants in the air. Oh, and with that said, you can actually look at the allergen counts, and sometimes the allergen counts, especially on the West Coast, sometimes are counting in on the nitrous dioxide as some of the material, because obviously it's an allergen, right? It can cause agitation to the lungs, especially if it happens to be in its solid forms, in its material. So anyway, providing pollutants in the atmosphere, yellow, reddish, breaded color. Anthropogenic source is often vehicle traffic, and it can cause pulmonary health problems. Volatile organic compounds, once again, they're volatile organic compounds, and even though the word organic is in there, it makes you think naturally occurring. It's not. They mean organic as meaning it's a hydrocarbon, so it has a carbon-based backbone, meaning organic, like living material versus non-living material in its statement. Sometimes organic, we think of it as, organic is termed to mean not natural, but oftentimes it's termed to mean, at least in the sciences, as in living things or having carbon backbone versus non-living things, stuff with a backbone or structure that might be a silica, for example. So it's not a carbon-based backbone. So don't think of it like organic food, right? Don't go there. They're made up of carbons and hydrogens, things like methane, butanes, propanes, octanes, so on and so forth. Natural sources, plant, animal emissions, so breathing, right? Decomposition of organic matter. Anthropogenic, so the non-human, or the ones that are human-induced. Primary is combustion from automobiles, trucks, buses, and other fossil fuel motors, as well as evaporation of gasolines and other chemicals, especially if they're surface-sitting chemicals. So that lovely oil sheen that sits on top of water can then evaporate off of the top of the water, and it causes all sorts of problems. Photochemical smog is the smog that is ozone and nitrous oxide, formaldehydes, and other gas combinations that can come together with solar radiation, and it forms a natural smog. And this is incredibly common in Los Angeles, and we call it a photochemical smog. It's highly toxic in its own right, which is why sometimes being out there, if you're on the West Coast, you're living in the Los Angeles region, especially if you work outside a lot and so you have a lot of exposure and you have to be out in all weather, so you have to be out there when it's foggy. It's those foggy conditions, you get that lung agitation. You'll actually feel your lungs feel heavy, and it's because you're causing basically a minor acute reaction to these materials as you're breathing them in. Ozone, we talked about way back in early modules, in the lower atmosphere, in the troposphere, is human caused. And if it's down in the troposphere, which means that it's not in the stratosphere, the next layer up where it's supposed to be, it's down here with us. If it is something that we're breathing in, it causes things like respiratory issues and heart problems. As we're going through. Air quality index is incredibly important, and they run it daily. It's part of our daily weather reports, and we often talk about the AQI when we're talking about it, and it's just letting us know how many of these solid particles, so organic volatile compounds, the ozone in the lower atmosphere, carbon monoxide, sulfur dioxide, and nitrogen dioxides are in the atmosphere at this time. And we put it on a range scale of 0 to 500, 0 being not there, 500 being extreme conditions. And we will actually tell you, based on those values, how safe or how much outdoor activity you should have on its various sets. And here is an example of what we consider good quality air, moderate quality air, unhealthy or sensitive for groups, unhealthy, very unhealthy, and then hazardous. The place that I've had the most exposure to this is out in Montana, where there's a lot of wildfires, and we will get a lot of information when you're out there on if there's wildfires burning within a certain area of the region. They'll tell you the air quality just so that you're not goofing around out there, because it really does have its toll on you. You can actually feel your eyes like itchy at the end of the day because of all those particulates in the atmosphere. Effects on wind or horizontal transportation, meaning the air moving on its horizontal axes across the Earth's surface. High concentrations of pollution within small areas can create its own little region of air conditions, and we will actually see things like air pollution settle into a region and not leave that locale for multiple reasons, one of which is that the air just can't move the material because it's thicker than or it's heavier than the air around it. And so it creates these little inversions that basically hold the concentrated material in its location, and it can't quite blow out of the region. This is also known as an eddy, and we will see very variable air mixing, but air mixing within itself in that one location. So it's kind of spinning on itself instead of mixing with the air around it, making it hard for that atmospheric air that's highly polluted to disperse, right? Dilute itself. So dilution is the solution to atmospheric pollution. Wouldn't one of my meteorology professors be proud of me remembering that? Inversion can trap the air pollutions near the Earth's surface, and keep in mind this inversion is pretty easy to come by, since these pollutions are often being produced by fossil fuel burning and things like that, which also has a natural heating to it. So it's creating its own little environment within itself. Think of the heat of the city, right? This will affect atmospheric stability. So it will make it actually atmospherically stable in this location. So we'll have no vertical mixing, right? Because it's its own little warm bubble and it's all hanging out by itself in its own location. There are some different things that we can do to improve air quality. One of them is regulation to actually improve air quality, so creating things. And some of those regulations that we've done in history is the 1970s Clean Air Act. Then there's the Clean Air Interstate Rules. And then there's the cross-state air pollution rules, which is also why we do things like having our cars inspected, right? So inspection. As far as what that did, it actually created a counteroffensive on air pollution to help with these concentrations on air pollution within regions by breaking